I'm Mike Breen, Public Ordnance Officer for the American Mathematical Society, and I'm talking with Guillaume Riesen, who, believe it or not, is a juggler and a recent graduate of Brown University. And Guillaume is going to tell us a little bit about the math involved with juggling. Guillaume, is there math involved?
There is, in fact. There is a system of notation for how the balls move from hand to hand. It's called site swap notation, and it's a series of numbers that define the paths of the balls. So for example, a 3 represents a ball being thrown from hand to hand and staying in the air for 3 beats before being thrown again. So this pattern is a 3-3-3 pattern. Then there's 4, which is a straight up throw that goes back to the same hand that threw it, and a 1 is a pass, and a 2 is a hold. So for example, we can have a 4-4-1, and we can continue that, 4-4-1, 4-4-1, and it's a full juggling pattern defined by the numbers 4, 4, and 1. A 5 is like a 3 but higher, so you can have a 5-3-1. It goes across and can also repeat, and so on and so on. So there are a series of numbers that can be used to describe all these different patterns.
And the beats, as people watching, that almost correlates with the height of the ball, right?
Yes, at least the frequency of the throws. So if you have a 3 that's low, it has to be faster, and a 3 that's high can be slower. But a 5 at this height would have to be much faster in order to be 5 beats at that height.
And if you're just looking at a series of numbers, can you tell if that's a possible juggle or if it's going to be hard to juggle?
I'm not very good at that yet, but I think more advanced site swap users could. You can look at a series of numbers and figure out, for example, the amount of balls in the pattern by adding up a repeating chunk of it and dividing it by the amount of different throws, I think. So the 3-3-3 pattern, the average is 3, which means there's 3 balls in it. Same thing with 5-3-1, that adds up to 9 divided by the 3 throws. There's 3 balls in it, and so on and so forth.
Yeah, so people looking, you've got 3 balls there, and a lot of you might not be able to tell the difference. You know, an amateur, you might say, but there are different patterns still using the same number of balls.
Yes. So site swap doesn't describe the entire pattern. For example, this is a 3, but this is also a 3, because the pattern of throws from hand to hand and the way that the balls are traveling is actually the same, even though the positions of my hands are different. And you can also do different catches, different locations of throws, and those are all still, by site swap definition, 3s.
Mm-hmm. And you did mention before the camera started rolling that you were kind of involved yourself as you were growing up in math, right?
Yes, I was a member of the math league, proud member of the math league in high school, and my mom was actually a math teacher in high school as well.
And does that background, you think, help you juggle, knowing math?
I don't know about that. I think it might help me appreciate some of the finesse of the more advanced site swap patterns that are hard to describe otherwise. But I think anyone can juggle with any background.
And so you want to show off some more?
Sure, I'd be glad to. This is a 5-ball cascade, site swap 5-5-5-5-5. And this is a 5-ball half shower. Same site swap but different throws. And with 4 balls, we can go into a 4-ball Mills mess, which is actually still just a 4-4-4-4 side swap wise. The hands just move to different locations. 4-ball columns, and down to 3-ball Mills mess. Do a 3-ball factory, which everyone likes because it looks different. 3-ball reverse factory, and roll behind back.
That's excellent.
Great.
Very good. Nice going. And so that's Guillaume Riesen, who's a recent graduate and has taken a lot of math courses and has a math background and is a fantastic juggler. And so for example, like the 5-5, that means each ball was up there for 5 counts.
Exactly.
5 beats. And so that's great, Guillaume. Thanks very much for doing all that.
Thank you.